All right, geometry. So here's a couple good word problems involving volume. So this says a spherical balloon has a 14-inch diameter when it is fully inflated. Half of the air is let out of the balloon, assuming that the balloon remains a sphere. What is the diameter of the half-inflated balloon to the nearest inch? So again, just to kind of draw you a picture. So here is the fully inflated balloon. It has a diameter of 14 inches. Half the air is let out, which means that it loses half of its volume. So if we take away half its volume, now we're this. Now, again, it's not as simple, oh, let's just take half of 14, oh, it's 7. No, it's not that simple. So now we have this. We don't know what the diameter is. We need to figure out what it is. All right. So the first thing we can do is we can find, so step one, we're going to find the original volume. So volume equals 4/3 pi r cubed. Now, if the diameter is 14, the radius is half of 14. The radius of the original balloon is 7. So we're going to find the original volume by doing 4/3 pi times 7 cubed. So I'm going to do it on a dinky calculator. Actually, no, I'll do it dinky calculator, sorry. So 4/3 pi times 7 raised to the third. So I get 1436.7 blah, blah, blah. Do not round, right? Leave this alone. So now we need the balloon to lose half of its volume. So step two, take half the volume. So half of 1436.7 blah, blah, blah. Again, and on my calculator, I'll just put divide by 2 and it does it for me. 718.37 blah, 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 blah. That's half of the volume. And now we're going to use this half of the volume to work backwards and find the radius, which will then help us find the diameter. So step three, another volume equation. Volume equals 4/3 pi r cubed. Plug the 718 in for the volume. That equals 4/3 pi times r cubed. Again, put the pi up top here. So this would be 4 pi over 3. To get rid of the 4 pi over 3, multiply by the reciprocal. So we're going to take this and multiply by 3 over 4 pi. Again, use parentheses times 3 over 4 pi. So again, I'm just going to, on my dinky calculator, I'm just going to go times 3 divided by, and in parentheses, 4 pi. Again, if you're using Desmos graphing calculator, you should copy and paste. Copy and paste this. All right, and maybe I'll show you at the end, just because I didn't want to lose my answer here. And there's what I get for r cubed. 171.5 is r cubed. And now we talked about this in the other video. To get rid of the cubed, you must take the cube root. And I will show you this in Desmos graphing calculator. I'll show you the whole problem in Desmos graphing calculator. Okay, give me 1 sec. Again, just trying to avoid losing the ink there. Okay, so let's go there to Desmos graphing calculator. Let's clear this all up. Oh yeah, delete it all. Here we go. So the first step was finding the original volume, 4/3 pi times 7 raised to the third. Okay, there it was. So then we took that and divided it by 2. So I'm going to take this, copy and paste. And I guess I'm going to take half of that. So take half. So 1/2 of that number. There we go. Okay, and now we're going to take this number and multiply it by the reciprocal, which is 3 divided by 4 pi. Notice my 4 pi stays intact. There's my 171. And now I'm going to go into my functions, find my miscellaneous nth root. Do it down here. Sorry, I didn't mean to do it up here. Down here, functions, miscellaneous nth root. I'm going to find the cube root of 171.5. And there is my radius. That is your radius. The radius is 5.555. They want the diameter, so times that by 2. So we're going to take 2 times, we're going to copy and paste that number. Copy. And there we go, 11.1. It says round, oh, sorry, wrong one. It says round to the nearest inch. So we're going to go 11, because 11.1 does not round up, and that would be inches. Okay, there's problem number 1. All right, next one. Okay, it says an ice cream vendor presses a sphere of frozen yogurt into a cone as shown below. If the yogurt melts into the cone, will the cone overflow? Explain. So this is a basic comparing the volumes question. We're going to find the volume of the ice cream. Now, right now it's a solid. If it melts and turns into a liquid, one of the properties of your physical states of matter is that it should be the same amount, right? Salt or liquid. Okay. So we're going to see if that volume of the ice cream, and again, the ice cream is a sphere. You just can't see it, right? It's a sphere. Is this volume bigger than the volume of the cone? If so, it's going to overflow. If the volume of the yogurt is not bigger, then it will not overflow. So the ice cream is a sphere. Let's find the volume. So the volume of my yogurt is equal to 4/3 pi r cubed. That is 4/3 pi, and the radius is going to be this length right here, 4. And when you do 4/3 times pi times 4 to the third, I get 268.08. So that's the volume of yogurt. So now let's do the volume of the cone. The volume of the cone is a cone. Remember from section 11.5, I think, that it is 1/3 the area of the base times the height. Of course, it's a cone. It has a circular base, 1/3 pi r squared times h. 1/3 pi. The radius of the cone is the same as the radius of the spherical yogurt, 4. And then the height is going to be that number, 12. So now we do 1/3 times pi times 4 squared times 12. And I got 201.06. So the volume of the yogurt is more than the volume of the cone. That means it's going to overflow. So here I gave you some choices. So is it going to overflow? Yes, because the volume of yogurt is greater than the volume of the cone. If it was no, it'd be because the volume of yogurt was less than the volume of the cone. And there we go. All right, great. Let's see what the next one entails. All right, so we're going to find the volume of the figure. So this is a composite figure. It might be difficult for you to see this, but this is like a cylinder with a semi or hemisphere on top. So if I try to draw it, it would look like this, and then it has this hemisphere on top. Okay, that's a pretty crappy drawing, but I try my best. So let's start with the volume of the cylinder. It is the area of the base times the height. Again, the base is a circle, pi r squared times h. So this 4 is the diameter. So that means your radius is 2. So pi times 2 squared. And the height of the cylinder is that 2.5. Okay, so that's going to be that part. Okay. And then to find the volume of the hemisphere, it's just going to be half the volume of a sphere. 1/2 times 4/3 pi r cubed. The r is the same radius as the cylinder's base, 2. So 1/2 times 4/3, we've done this before, is 4/6. So 4/6 times pi, and again, times 2 cubed. And we're going to add these two together. Okay. So pi times 2 squared times 2.5 plus 4/6 times pi times 2 cubed. And I will type this into the calculator for you. Let me take a picture. Okie-doke. Calculator's here. Let's get rid of all this stuff. Okay, so we're going to do pi times 2 squared times 2.5 plus 4/6 times pi times 2 to the third. And I got 48.17. I believe it says nearest tenth. Yep, so 48.17. 48.17, the 7 makes the 1 become a 2. 48.2, and that would be centimeters cubed. 48.2, and that's centimeters cubed. Go all the way down to the bottom, centimeters cubed. Great. Okay, I'm going to make a second video covering the last two problems.